Setup number 1. Ferrite core, 32 gauge wire wrapped this way, moving around the core this way, 28 gauge wire wrapped the opposite, moving along the same direction of the core, wound over top of the primary, called A, secondary B, connection posts for A coils 1 through 4. There's 4 quadrants. 1, 2, 3, 4. Wave is sent in, which will be in video number 2. This is 3 inches by 2 inches by ½ inch ferrite core. This is 32 gauge meg wire and 28 gauge meg wire. The following is used to amplify any noises or current from in the coil. We have here a PNP transistor which listens here. The voltage is driven up through the NPN transistor, from there going to the speaker, allowing us to hear any static or supposedly electrons. This is our driving circuit, and shown here in the drawing we have a battery that's driving the 555 timer, which is then in turn driving an NPN transistor, driving the electrons from this battery, allowing them to perform the loop. Here we have resistors, so we can adjust variable resistor to adjust the on-time pulse and off-time pulse. Here we have a driver for the base, or variable resistor for the base of the NPN transistor. And this is the power supply and the NPN transistor used to drive our wave going out. Okay, this is oscilloscope 1, showing our light bulb up here that is being driven by our 555 timer circuit. This is the wave that is being produced on a CRT oscilloscope. Moving over here, we can now see the same wave being picked up on this oscilloscope, and we're showing 740.7 hertz, and our output is 6.16 volts. Now I am going to connect our driving coil to a coil like this. Ferrite core, wound with 28 gauge wire, and let's see what our scope looks like. Okay, we now have our coil hooked up to our driver, and this is how our wave has changed. We're getting peaks coming up on the top, and down here we can see the back EMF, although not very strong. We can definitely see a line in the CRT. Moving over to the other scope, we can see the back EMF quite present there. And we're showing jumps up to 9 and 10 volts. And as we can see in here in our scope, our back EMF is kind of popping or showing up. Alright, here we have our coil showing our back EMF on our scope. Here is positive, here is negative. I also have the green wire connected to this rectifying diode here. The band is on the top. Thus, now I'll take and I'll touch the bottom onto the negative, which should bring out the back EMF, or the positive, off of here. And as you see this, our scope shot will change. As you see, it pulls out the back EMF. Again, when I take it off, the back EMF appears. When I connect it, back EMF is gone. So as review, what we've done here with our 555 timer is given a wave, sent that wave into this coil, This coil is hooked up here with positive, thus the electrons are flowing from the negative terminal out to the positive terminal. We then took a rectifying diode to catch the bottom of the wave here, or the back EMF, connected it up, and found that once that was connected, that our wave went back to a regular square wave. Alright, here's our ferrite donut as described earlier. We have 32 gauge wrapped in a clockwise direction that is running counterclockwise around the ferrite core. We then have 28 gauge, which is counterclockwise and is also wound counterclockwise around the core. We have 4 segments, 2 by 2, giving us 1, 2, 3, 4 segments. What we're going to do is we're going to connect in series segment 1, segment 3, and segment 4 to our 555 driver. We are then going to take measurements with the oscilloscope off of this section of coil, or section 2. We now want to take measurements using our oscilloscope from section 1, section 3, and section 4 to see what is different with this coil versus the other coil we previously tested in our other experiment. Using the same type of wave pattern as well, we want to make sure we check what's happening over here to see what kind of differences there are. We're now going to use the same pulse as described before and connect to our donut from here. Our negative will be connected here, skipping this quadrant, going to quadrant 3, going to quadrant 4, and the positive being connected to here. We're going to have the scope connected exactly the same as we did in our last experiments, connected to here, and we'll look at our waveform. Now, as we can see, our waveform is different in this case. The back EMF has changed. As well, this scope will show more detail as to how there is change as far as down in here is concerned, where it's taking longer for that to come back to 0. We're now going to connect the scope on the right to our second quadrant. Scope number 1, the scope on the left, will be left connected here, so we can compare the two forms. As we see now, quadrant 2 has little rises coming right out of here. The wave pattern looks the same. The voltage is less. If we have a look at our other scope on our driving coil, we'll see that it's as it was before. It hasn't changed.